For number 1, we are given the expression log base 5 of 125 x to the third. And we are supposed to expand this expression using our properties of logarithms. So first of all, we see a multiplication. This is understood to be 125 times x cubed. And we know that a multiplication can be turned into an addition of logarithms. So we could rewrite this as the log base 5 of 125 plus the log base 5 of x cubed. Now this first expression is something that we can actually evaluate. Remember, the question that you want to ask yourself when you see something like this is 5 raised to what exponent is equal to 125? And 5 to the third is 125. So that means that this entire term simplifies down to just a plain old 3. And then for the second part of this expression, whenever we see an exponent inside of a logarithm, we can pull it down in front as a coefficient, as a multiplication. So we can rewrite the second part as 3 times the log base 5 of x. And that would be as much as we could do with that one then. Number 2 is the natural log of x squared y all over 3. So we already said that a multiplication of logarithms, a multiplication inside of a logarithm, can be turned into an addition of logs, and a division inside of a logarithm can be turned into a subtraction of logs. So that would give us the natural log of x squared plus the natural log of y minus the natural log of 3, since it's in the denominator. And then the only other thing that we could do with this is, since we see this exponent here, so we could pull it down in front as a multiplication. So that would give us 2 times the natural log of x plus the natural log of y minus the natural log of 3. Number 8, we have the log base a of the 5th root of a to the 4th b over c squared. Alright, so the first thing that I'm going to do is I'm going to rewrite that 5th root as an exponent of 1/5. So all of this is the same as log base a of a to the 4th b over c squared raised to the 1/5 power. And then because I have that exponent of 1/5 inside of a logarithm, I can pull it down in front as a multiplication. So it would be 1/5 times the log base a of a to the 4th b over c squared. And then similar to number 2, we can turn this multiplication into an addition of logs, and we can turn this division into a subtraction of logs. So that would give me the log base a of a to the 4th plus the log base a of b minus the log base a of c squared. But now all of this is going to be multiplied by this 1/5 that I brought down in front in this step. And then I have a couple of exponents in here that I can bring down in front of their respective logarithms. So that would give me 1/5 times 4 log base a of a plus log base a of b minus 2 log base a of c. And then I'm going to distribute that 1/5 to get 4/5. 1/5 times 4 would give me 4/5 log base a of a plus 1/5 log base a of b minus 1/5 times 2 is 2/5 log base A of C. And then one more step that I could do with this one is, since I have variables that match here, log base A of A, we would ask ourselves, A raised to what exponent gives me A? Well, A to the first is equal to A. So that means that this piece of it is really just equal to plain old 1. And 4/5 times 1 is just 4/5. So that entire first term there turns into just 4/5. And then I have plus 1/5 log base A of B minus 2/5 log base A of C.